For those that are, viewing online, they can listen to our awesome conversation.
We talk about it in your class.
Talk about whatever it is.
You're recording like in this class.
Say, I don't know. It was a question or statement? Keep going, stuff. Good. It's all right. I don't mind. It's a good conversation. All right. Juan, can you read for us? I know you watched the show, so nice and loud for us, please. Let's listen carefully. Juan's going to read, and we're going to identify what we know.
In the AMC series,
Louder.
The AMC series, The Walking Dead, there is a zombie apocalypse. Suppose that at the time the main character wakes up, zombies already rampant among humans. There is a human population of 800,000. After 2 days, 100,000 humans are dead. If the death rates are exponential, how long will it take for the population to be halved? When will you be the only person left?
Okay. So, in the show, as some of you seen, the zombies are taking over and there's not many humans left. So, hypothetically speaking, let's say there's 800,000 humans, okay? And we're told that after 2 days, 100,000 humans are already dead. If the death rates are exponential, so we use our function from yesterday, when you see that right away, when you see the death rates are exponential, when you see exponential growth or decay, start with that function right away that we talked about yesterday. Now, part A says how long will it take for the population to be halved? Halved. So, what's half of the initial then? 400,000. So we want to know, when is y equal to 400,000? So we're looking for this equals 400,000. Our A is going to be our starting value. So what's A right away?
800,000.
But the problem is this, you're not given a rate. Anybody notice that right away? There's no rate in the problem. So the first thing that we're going to do actually is figure out that rate. Before we can get to part A and part B, to do part A and B, we need to know what the rate is. But I can't do that just yet. But I do have some information. It says after 2 days, what?
100,000.
Or what? More have died. So how many are left after 2 days then? 700,000. Again, we started with 800,000. After 2 days, 100,000 people are dead now. So we have 700,000 left. So we know that at time equals 2, the value of y equals 700,000. And let's discuss this real quick before we go any further. When the time is 2, or 2 days, the population is 700,000. In math, in calculus, we call this a particular condition. And think about this for a second. Make logic of it. You're in the hospital, and the person comes up, or somebody in your family's in the hospital, and says, what is their condition? Right? Isn't that a term they always use? What is the patient's condition? And they tell you how they're doing, their status. That's really what they're telling you, the condition. So right now, this is called a particular condition, because this is the status of the human population at a certain time. So we're going to call this a particular condition. Okay? Particular condition. A term that you will see again over and over again. It's in calculus and in pre-calculus, both. Particular condition. Now, with that said, I know that T, I know Y, I know A, so I could find R in this equation here. It's going to be tough to do, but let's go ahead and do it. So let's plug in what we know into this equation. We know that Y is 700,000. So again, we're finding R. Y is 700,000 equals 800,000 times E to the R times 2. Again, so what are we doing right now? We're plugging in all our givens. That's all we've done so far. We plugged in our givens. The problem is this right now. See that R? Where is it located?
In
the exponents. And until Monday, when we learn about logarithms, we can't actually solve that just yet. Once we learn about logs on Monday, you can be like, oh, this is easy stuff now. You do it by hand. And you can easily do it by hand for logs. But in this case, let's use our calculator. So remember from yesterday and the day before, if we want to know when the population equals 700,000, we put that into Y2. And we put this one into Y1. Okay, again, put this in Y2. So go to your calculator, put that part in Y2, put that part in Y1. And instead of a R, what are you going to put? Here's a calculator? X. Again, whenever there's a variable in our problem, on the calculator, it usually shows up as X. So we're going to put an X in here. So put that in Y1, put that in Y2, and we're going to search for what? What are we going to look for in these two graphs?
So I got to put
700,000.
Is it
I mean, the rate.
No. The question I'm asking is different, guys. We're searching on the graph for what? Where the two curves do what?
Intersect.
Intersect. That was the question I was asking. Sorry. So we're looking for their intersection. On.
In the thing you put for Y1, you put 880. Oh yeah,
800,000
X.
E to the 2X.
Oh yeah. E.
How do you do E?
Oh no. How do you do E? Okay, to do E, you press second and then the natural log button. It brings it up as an exponential. So you press second, E to the X, and then we're going to put 2X there. Again, why did I put 2X there, guys?
Because of the thing. Because of
Because that's how
R2
it's used
and the
in
exponential thing. As the exponential thing.
Yeah, what was 2 though? 2 was the time, right?
Yeah.
This is really R times T here. R times T. Ebony. As long as you have them all in the same parentheses in the exponent, short. You need a major parenthesis around your whole exponent. So if you put 2 and x in parentheses also around there, or inside of there, that's fine, but that's redundant. There's no need to. To make it easier on you, just write it like this. Because if you put parentheses 2, parentheses x, it's going to do e to the 2, then it's going to multiply that by x, which is different. We want parentheses around our exponent always, always, always. The whole exponent.
Yeah, that's what I said. But
That's fine. But you don't need the 2 or the parentheses around the 2 and the x. You don't need it. You asked, can you put parentheses around the 2 and parentheses around the x?
I still put the X first.
Oh, sure. Or you can just put x2 instead of 2x. Same thing. That's fine, yeah.
What would the window, like, what would you change?
That's what we're going to figure out right now. That's exactly what we're going to figure out.
Oh.
It's going to be tough. What was that? And? Alright. Now, let's take a look at this. If I hit zoom 6, watch what happens. Oops, you can actually see it. Let's do this over here. If I hit zoom 6, it looks like I've got some sort of exponential growth function, right? Even though I know it's decay. But that's my original function is decay. What have I plotted? I plotted 800,000 e to the 2x, which is growth. Because technically, if you plot this function, that's positive, isn't that? See right here? Isn't that a positive value? So it's going to look like growth. Because this is not my real function for this problem. This is only what I'm using to find r. Remember, we're finding r right now. So, now I have to look and say to myself, the line y equals 700,000 is going to be a horizontal line up at 700,000. So my y max has to change clearly, right? So let's change my y max so I can get up there. So my window, what might I make the y max now?
10,000, 8,000.
I would say maybe 800,000, just so I have encompassing both graphs. So let's try 800,000. There's my growth function, and there's my 700,000, right? Where does it look like they intersect, guys? It looks like it's on the y-axis, doesn't it? Like almost right there. We're talking right here. That's the intersection. But I know that they're not intersecting on the y-axis because then the value of the rate would be 0. Right? The y-axis, on the y-axis, the x-coordinate is 0. I can't have 0 as my rate or else there would be nothing changing. So what can I do to look at this better? Yeah. So on the x-axis, take a look, everybody. Isn't this -1? And this is +1 still. Because my x is still going from -10 to 10. So maybe I should change this from -1 to 1. So let's go to our window one more time. Hit window and change the x min to 1 and change the x max, -1 and change the x max to +1. And let's see what happens now. Graph. There's my exponential growth. And now I can see that it doesn't intersect on the axis, right? Clearly, this is again -1, 0, 1. This is 0. This is 800,000. That's my domain from -1 to 1, and my range is from 0 to 800,000. Now, the intersection is right here. It's close to 0, isn't it? Yeah. But it's not 0. So, I could sit here and say, all right, well, you know, I could just hit trace and try and go over until I get near it, and it looks like it's around -0.063 but I don't know for a fact, right? What should I do? Second, calculate. Very good. Calc. Number 5. Now, my cursor is already on the spot. If it were not, excuse me, I got the hiccups. If it were not, if it were all the way off the graph like that, and you would see that it's off, you got to press left to come backward. Press left, and you'll come backward. And we're going to see the tick marks start to come in. See it flashing now? It's flashing up here. Hit enter on the first curve. Enter again because you're right there. And then it says guess. Just hit enter one last time. And you'll see the exact value of the intersection. And take a look. That makes sense because it's 700,000. It needs to be. That was our second function. So for R, let's write R equals negative 0.0668. Just around. Okay? That's the rate. So we haven't even done part A or B yet. All we've done is solve for the rate so far. Let's go back to our actual smartboard file. Let's take a look. Bring it back to the problem. All right. So when we do this, this is what we see, and this is what I just showed you guys on the other graph. And here's our rate right here. Okay, so let's write down R equals negative 0.0668. Now,
Oh, it's negative?
why is it negative, guys?
Because it was on that side.
Yes, because the intersection is on the left-hand side. See the negative sign? The intersection is on the left-hand side, so it's negative. Also because, isn't it decay? Aren't people dying? So shouldn't the rate be negative? So it's logical. The humans are dying in this episode, right? So,
On market there. When does
Whichever.
it start?
the whole season just ended.
I know.
A few months ago.
It's actually kind of good.
No, but if
Right.
people are dying, shouldn't
So-
it be in the positive area and then?
No, it will be, and we're going to talk about it in a second. But remember, Amber, what we're doing right now is finding the rate of
Okay.
the overall function, okay? 1 second, Jose. Now, focus, focus, focus. Our function earlier, we knew the A value was 800,000, but we were missing the R value. Now we have the R value. So we could say 800,000 times E to the negative 0.0668 T. That's the actual function we're going to use for part A and B. Again, the first thing we just did was solve for the rate. We took that rate and we plugged it in right here for that value. We took the A value, we plugged it in right here, and we ended up getting this equation right here. Well, right now we don't know T. Look at part A, Rosie. That was only for that condition, right? We were told that when T equals 2, there's 100,000 humans dead. But for part A, it says, how long will it take for the population to be half? So are we going to be solving for T now? So we need to leave T as a variable. Again, take a look at this function. The next part, we're going to be solving for T. You saw the question? You had a hand up.
Yeah, what was the rate about? I mean, what was the rate, like actually talking about?
The rate is the rate of change of the human population. That's what we're solving for. So in the problem earlier, we had this function, but we didn't know what the rate was the humans were dying at. So we used that condition there to help us with it. Okay, to help us with it. Jordan, and then I think Mia had a hand up. There were 2 hands beforehand over here.
I figured it out.
Figure it out?
Oh,
Other?
my name is-
Ebony, thank you. I'll get to you in a minute. She answered it though? Perfect. Owen.
Oh, you put the Y back because you took the time away too, right?
Correct, because remember, a minute ago, we used this condition, right? 700,000 and 2 to solve for R. But our general function is still this right here. We've taken the general function, plugged into A, plugged into R, so we now have the actual function. Now we have to say to ourselves, how long will it take for the population to be half? What's half of 800,000? So what we're going to do is put 400,000 here, really. So this is what our Y2 is going to be now. So let's go back to our graph, please. Let's go to our graph. Go to your Y equals. Instead of 400,000, instead of 700,000, make that 400,000. Now, look at your E function. That's not right either anymore because we're not doing 2x anymore. We still have the 800,000, but it's no longer 2x. Go back to the function that we were just looking at. This is going crazy, this smartboard. Come on.
I think it's the time that we have.
There we go. If we go back to our function, now look at the value that's here. Negative 0.0668. That's what's going to go in my y equals. Okay, so again, this is going to go in y2 right here. This whole portion is going to go in y1. And we're going to try and find the intersection again.
So,
Negative 0.0668x, close parentheses.
Is this supposed to be two straight lines?
Okay? Should it be what?
Is this supposed to be two straight lines?
Well, let's see what it looks like. If we just did graph on the units we had earlier, if we just did graph on this one, we're going to see that's our original function, and there's the other one, right? So, go back and look. It looks like the population is decaying, as we said. It's going down, and we want to know when it's going to hit this flat line here. So this is the population decaying up here, it's decreasing. This is a constant or a flat line. Where are they going to intersect, guys? I'm not asking specifically, I'm asking generally. Where will they intersect? Yeah, somewhere in the first quadrant. Somewhere down the road, right? This is the first quadrant here we're looking at, right here. That's the first quadrant. So somewhere down the road, I'm sorry, this is the first quadrant right here. Somewhere down the road. Well, let's see, actually. What did we put for our y? Yeah, that was the first quadrant. All right. So let's go ahead and change our x max. Leave her alone. Focus. Change our x max. Let's change our x max to about, I don't know, let's say 40 for now. Okay, see what happens with that in graph. Take a look. There's your exponential decay function, right? Doesn't it look a lot better now? Now that we've changed our x max to 40? So all we did just there was go to our window and make the x max 40. So we can see now, look at our first quadrant. In our first quadrant, they intersect right here. Okay? So how do you find that intersection again? Second calc. Very good. Number 5. First curve, go over. Okay, I'm close. Stop. Stop, cursor. Thank you. Hit enter. Second curve, hit enter. Guess between, hit enter. So, what does this mean, 10.376?
That is.
What does that represent?
Time.
To be had.
The time it takes, okay, in what units though? What is it? Why is it days? Yeah, look at the units in the problem. It uses days, right? Guys, you all need to stop talking a little bit less. Please focus. Come on. 10.38 days. In 10.38 days, that is the population. Okay? So, yeah, we could round say after about 10 days, half the people on the earth will be alive.
That's only part A.
Okay, that's part A.
So that's 10 days, that's the time, the team.
The time, T, absolutely, which is 10 days. Think about the time, right? Earlier we said after 2 days, there were 700,000 left. So our units are going to be days. Okay? Now, quickly, let's go to part B. Part B. When will you be the only person left? What do I do here? What do you find? Good. Again, when there's only you left, how many people are left? What's the population? So go to your Y2, everybody. Go to your Y2. Instead of 400,000, just make it 1. Hit clear, and then hit 1. Now, what you're going to notice is this, first of all. Hit graph again with this. You're going to see the exponential decay function. You're not going to see much more, though, after that. Notice you don't see anything else? Because this. Think about it logically, guys. Isn't this 800,000 up here?
Yeah.
This is 400,000? Where's 1? It's like down here, isn't it? It's pretty much on top of the x-axis because we're so zoomed out.
So you gotta zoom out.
So what we're going to have to do to figure out where this intersects, clearly it's going to be down the road a little further, is to zoom in between 0 and 2, right?
Can we change our X max?
So not our x, we can change our x max to go further, absolutely. But we should also change our y range so we can zoom in and look at this clearer. So for y, everybody do this. For the y value, go from, instead of negative 10 to 800,000, go from negative 1 to 2. So my y min and y max go from negative 1 to 2. Because I care about that little region right here. You know that little region? From 0 to 1, that's where it's going to intersect, somewhere in there. So I'm going to go from negative 1, which is like here, to 2. Relax. Now after that, because it's going to only give you line for now. That's why I'm explaining. Also though, note that it doesn't intersect until down the road. Okay, somewhere down the road. You are not invited to talk when I stop talking. I'm going to say it for the last time. Down the road means further down. Again, here this was about what, like 40 we went to last time? So let's go a little bit further. So we have, for example, here, let's say 200. Let's try and see what happens. Let's graph these together. So what you're noticing, and it's going to come up on the screen. Okay. What you're noticing is this. This here is our y min, which was -1. This is our y max, which is 2. This is the line y equals 1, which is in y2 right here. That's y equals 1 right there. You can't really see much of the exponential decay because it's coming from 800,000 and it's only falling down here. So I have to keep going further to the right. Okay, so instead of x max being 200, let's change it a little further. So instead of it being 200, let's go to our window and make the x max now 300 and see what happens then. Hit graph. We're going to notice that our exponential decay, now we can see that it drops down. And we can finally find this intersection. And we are so zoomed in right now that this doesn't look like what we had earlier, even though it is. If we zoomed out right now, we would have 800,000 starting here. That's our decay function. And over time, there'd be a little line y equals 1 that will eventually intersect with it far, far down the road, which is that intersection we're looking at. Okay, so this was, if you remember, 300, which means this is around 150. So our intersection is going to be somewhere in between there. Okay, again, find that intersection by pressing second, calculate, number 5. It's going to say first curve. We'll take a look. See this 149? Where's 149 on this graph? Okay, on the left. Think about it. Isn't this 0? And this is 300? What's halfway between 0 and 300? So isn't that where we're at right now? So if my cursor is somewhere in the middle here, in this range, I got to press to the right. So let's press to the right and keep changing this until it gets to like 200 and change, or until the cursor appears. See the cursor now? It's appearing right there. Press it one more time, it's getting closer. So we're around 200 days in. And I don't know the exact value, so I press enter, enter, enter. It'll give me the exact value. So when are you the only person left? After around 203.5 days.
So everybody else will do. So how
Okay.
you supposed to make more decay?
Say again?
How you supposed to survive?
That's the once there's one person left, human population is pretty much done.
Oh, God.
That's why you always need a male and female for any situation like this. Okay?
Nah,
I don't know how you're gonna figure out how to do this yourself. Yeah. All right, next example. We got one more to go.
It's like anyone out of there.
That's just high.
Okay. Look at the bottom one now, or the back page now. Flip over to the back page, look at part B. Now, for part B, what I'm going to do is this. For the sake of time, I'm just going to introduce this. I'm not going to go through all this math that I put here. What I'm going to tell you is this. The other day when we did money or investments, we talked about N, R, and T. R is the interest rate. T was the time that you invested for. A was the amount you invested, the same as what we've done the whole time. But N was our new variable. And if you remember, N was the number of compounds. So if it was compounded quarterly, N was 4. If it was compounded monthly, N was 12. If it was compounded daily, N was 365. And we made a table for this. So if you need to reference your table, that's fine. Now, the question becomes this. What happens if I compound it continuously? So not daily, not monthly, but every millisecond, I compound the money. What does N become? What kind of a number?
Infinity.
Very good. A very large number or infinity. Good one. So we're looking as N goes to infinity. And this formula, as N goes to infinity, becomes what we had from yesterday. Our general exponential growth or decay function. So when N is equal to infinity, when you put infinity in here and here, really, you end up getting this function out. So this is the function that we're going to use for money. This is the function we're going to use for money when it's compounded continuously. That's the key word. That's why it's italicized. So make sure you put an underline or something around that. If you do a problem for homework that says compounded continuously, or on your quizzes, this is the formula you're going to use. If it does not say compounded continually, if it says compounded quarterly, you're going to use this function that we started with, the one that we had from the other day right here. Okay, so our two functions that we're going to use are this function, if it doesn't say continuously, if it says quarterly or monthly. If it says continuously, we're going to go to this function right here. Okay, I want to get to the last example. We'll have time. We have about 6 minutes. Let's do it. So for example 3, it says you decided to deposit $2,500 into a savings account that accrues interest at a rate of 5%. Annual interest rate, thank you. The interest can be compounded 3 ways: continuously, monthly, or quarterly. Any of those 3 can work. You get the option as an investor.
So don't you have to do all three?
That's exactly right, Enrique. Very good. We're going to do all 3 of those. We're going to see which one works. Which option should you choose? That's the first part. Second, for the option you've chosen, how long will it take before your investment doubles? What's your investment, everybody? How much money?
25 G.
Good. $25,000 or $2,500.
Okay.
That's our A value. What's our interest rate?
5%.
Are we making money or losing money?
Losing.
Uh-oh. I hope we're making money. You're investing money. When you invest money, your goal is to make money. Okay? It's a positive interest rate.
Hey. That's what you have to pay when it gets money.
You are putting in $2,500, and hopefully within a year you have more than that in the account. So that's the profit you make. Okay? Next, how much time went by?
2 years.
2 years. Okay, the amount of time that went by is 2 years. So we've got almost all of our information right now. The next part is this. We need to distinguish and decide what kind of formula we're going to use for these. Oops. What kind of formula we're going to use. So let's go ahead and do this. For compounded continuously, okay, we're going to do this. Next, for compounded monthly and quarterly, we're going to use the other formula that we have.
Okay, so continuously is AERT.
That's correct. And compounded at some other rate, doesn't matter what that is the other formula. Here's how you can remember, people. Ready? Think about this logically. If it's compounded quarterly, n is 4. If it's compounded monthly, n is 12. You have an n value, right? So you use the bottom formula because there's an n in it. But when it's compounded continuously, n is infinity, which you can't do. That's why there's no n anymore in the first formula. That's how I remember it. If you want to remember which formula to use, if you have an n, if you have monthly or quarterly n value, use the second formula. Since continuously you don't have n is infinity, you got to use the first formula.
So are we doing monthly or quarterly?
We're doing continuously, monthly, and quarterly. So this is going to be for monthly, and then for quarterly it's the same formula, but our n value will change. Okay, so what I'm going to do here is this. I'm going to analyze all 3. Let's go ahead and do that. The first one we got y equals 2,500 e to the 0.05 times 2. Again, all I'm doing is plugging in at this point. That's it. Just plug in. For the second part, I'm going to list the n values here below the arrows. What's the n value when it's compounded monthly? How many months are in a year?
12.
When it's compounded quarterly?
24.
What is it, Marcus? 4. Why is it just 4, Marcus?
Because it's 4 quarters in a year.
It's 4 quarters in a year. There's always 4 quarters in any whole amount, right? Like 4 quarters in a dollar?
Yep.
4 quarters in a circle, same idea. So for these ones, let's plug in. Now, you got to be careful, guys. A lot of calculator errors I see on this all the time. So just listen to what I'm going to say now. So that's for compounded monthly, and the only change you're going to see, and I'm going to make sure to emphasize this. I use a different color. That's not a plus plus, but a 1 plus. The only difference you're going to see is this. You now have a 4 here and here. Everybody see that difference with the 12? Again, when it's monthly, you have the 12 here and here. When it's quarterly, you have the 4 in both spots. The 4 in both spots. Now, there's a lot of room for error here. So if you want to write down steps, I'm going to quickly go over the steps to input this in your calculator. First, for the continuously compounded problem that we're starting with right here, I recommend that what you do here is do this part first, really, and then just multiply by 2,500. Now, when you raise e to a power, you got to press second and then the ln button on your calculator. You're going to press second. I'm going to go to the home screen, show you. I'm going to press second ln, which is e to the and then I'm going to put in my values, which is 0.05 times 2. 0.05 times 2. That's that quantity. I'm going to get an answer. That's going to be my actual increase value of my rate times 2,500, which was my principal value, or my starting value. So I get 2762.93. I get 2762.93. That's what I get for continuous compounding. For monthly compounding, this is very complicated to do. Do what's in the parentheses first, please. So I would do 0.05 divided by 12. I would start with this right here. Then I would add 1 to that. Then I would take that answer and raise it to the power. Then I would take that answer and multiply by 2,500. So let's do that together. Okay? 0.05 divided by 12. Enter.
004.
Good. Plus 1. Enter.
1.
Raise that. Again, you know the plus 1 comes from right on. The plus 1 is right here. We take that quantity plus 1. Raise that to the 24th. Because this is really the 20... Whoops. This quantity, 2 times 12, is really 24.
1.10.
Okay, give me one more second. So put a 24 in here. And then times that by 2,500. That will give you the quantity 2762.35. 27...
So is that monthly?
2762.35. Which one's better, guys? Which one do you make more money in?
Second one.
More money.
Oh,
First one.
First one.
Again, what's your profit? Your profit would be this quantity minus 2,500, because you invested 2,500, right?
Yeah.
This is how much you have, not how much you made. You made about $260 there.
So now do we do all the other parts?
Try the third one on your own. You can finish this up, and then you can try part B also there. Okay? Look at the notes on that line if you want to see how to get to the answer for this problem. This weekend, finish concept 55 worksheet, everything from it. This weekend you're finishing concept 55. You got it yesterday in class. All 6 projects, please. Marcus?